Hello everyone. Today I'll show you how to write requirements using Gherkin scenarios and execute them in your Simulink simulation with Python. Imagine creating a Simulink simulation representing your system. You meet with stakeholders to ensure alignment and that the functionality accurately represents the system being designed. Now we need to write our requirements. Writing textual descriptions can lead to errors, both logical and typographical. Using Gherkin allows us to execute scenarios in the simulation, ensuring consistency between the simulation and written descriptions. First, we will write our scenarios using Gherkin. Then, we'll explain how to extract and send data to Simulink using Python. Finally, we'll create automated tests using the Behave framework. Matlab Simulink allows us to simulate complex systems like modules, APIs, software, and physical systems. Gherkin lets us automate tests and create artifacts that can be shared across organizations, even with those unfamiliar with Simulink or programming. Combining these technologies strengthens simulations and enhances collaboration. First, ensure you have everything ready. You'll need Matlab, Python, and a code editor installed. I personally use Visual Studio Code with Python 3.10 and Matlab 2022b. To get started, open your terminal in Visual Studio Code and run. Pip install behave, user. Next, install the Matlab package. Pip install Matlab. To install Matlab engine, visit the Matlab engine repository. Find your Matlab version and the corresponding command. For version 2022b, I run Matlab Engine 9.13.11. In Visual Studio Code, install the Gherkin extension for better formatting. Once the libraries are installed, create the following file structure. First, two folders, one named Models and the other Scenarios. In Scenarios, create a file called restrains lamp indicator.feature and a folder named Steps. Within Steps, create two files, steps.py and interface.py. Open the Gherkin file and start writing the system behavior. This system focuses on the airbag indicator, crucial for regulatory compliance. For example, when the vehicle is off, the indicator should not be visible. When the vehicle is started, the indicator lights for a set time, known as the prove-out routine, verifying internal components. Finally, the indicator should display the airbag status. Gherkin syntax is straightforward. First, define the feature. Each scenario has a title and consists of three elements: given, when, then, representing preconditions, events, and actions. Using examples allows us to generalize statements and clarify our intent. Each sentence needs code definition to be executable. In steps.py, import behave and time libraries. We haven't used interface.py yet, but keep the reference. Identify each sentence and link it to a Python function using decorators. Given, when, then. For now, we pause each step for 200 milliseconds to verify step recognition and correct installation of behave before integration. Consider exploring the behave documentation for additional functionalities like handling variables or adding tables. To execute scenarios, navigate to the Scenarios folder and run behave. If successful, you'll see the same results as I do. If not, pause the video and check your installations or files for issues. In the second part, open your Simulink model and Matlab window. Do two essential things before proceeding. Add all project folders to the path for Matlab visibility and execute. matlab.engine.shareengine to establish a Python connection. Create two functions in the models folder. Set real-time datum and get real-time datum to send and receive real-time model data. Use setParam and getParam functions internally. SetParam takes 3 arguments: block reference, property to modify, and data. GetParam requires a block reference and requires simulation execution to function. Test these functions before starting Python code by running your model to ensure data transmission. Once confirmed, return to Python code and work on interface.py. The goal is to create a class named interface with two methods: send to model and get from model to facilitate the connection with Matlab and utilize previously created functions. Next, open steps.py. First, create a simulation instance with your model name. Generally, for given and when steps, send information to the model. For then steps, extract information. The general structure of functions includes pausing the step for a set time, converting data types if needed, and sending or receiving information. The step, waiting for the prove-out to finish, is an exception addressed at the end. Consider the data types used, whether numbers or strings, as conversion may be necessary. Steps may execute rapidly, so maintaining delays is advisable. Another tip is to adjust the delay to your system's needs. I wrote 200 milliseconds, but you might need more time between steps. Verify simulation functionality using assert, which flag errors if values don't match. Lastly, we address the prove out step. We need to verify that the indicator isn't executing the routine by checking the output values and stopping until completion using a while loop. Be careful when replicating this routine, as simulation or logic errors can create infinite loops. Finally, rerun the behave command and verify correct execution. Notice how Python sends information to Simulink and everything runs in real time. If you enjoyed this video, please like and subscribe. I'll continue uploading Matlab/Simulink and Python tutorials. If you have suggestions to improve this integration, leave them in the comments. If there's a topic you'd like me to explain in more detail, let me know in the comments. Thank you.